Seeing looks in depth at the processes of machine vision, both its strengths and its limitations. So if you think about it, a computer can't appreciate a piece of abstract art the way a human can. And that's what makes current research on machine vision very interesting. Not only are we looking at how computer scientists are trying to bypass these limitations, but we're also looking at how computers learn and become intelligent viewers in their own right.
So the person sits there, we wake the robots up and they look for a person and then they react to what they see. It's about representing the human, but it's also representing the human artist. So they appear to have three different styles, but in fact it's the same software, exactly the same software, and I just change the nervosity of the arm and something just after the camera, and that's enough to give different style. And it's the idea that if you have a class of art students, you teach exactly the same technique, they will have different styles anyway. When you study perception, you realize that we create everything we see. So it's interesting because in a certain way those robots, they can't lie because they really represent what they see, but when you look at the drawings, they don't look like reality at all. So it's very strange. And we do the same, we invent reality when we see things.
It's a collection of different data sets that researchers use to train algorithms to see the world. Whenever you take a photo of a group of people, it will recognize a face, for example. All of this is based on statistical data, on numbers. The title is ground truth, and that's the way the researchers call these data sets. It's like the truth for the machines. Why do we have these represent the world? So it's like 38 researchers. It's not the whole world, obviously. So is it maybe biased? We don't know.
The first screen we see the interpreter, and on the second screen we see the artist. The interpreter is actually looking at the world and tells us what it sees. And that's computer vision. And we don't know actually how a computer thinks or sees, so that's what we want to illustrate here in a way. And the artist is actually a kind of genetic algorithm we created, and it made images evolve in such a fashion that for us humans it's totally abstract, but for computers it's still a banana or a strawberry, and that's quite interesting. I hope people will retain the question that how much confidence do we have in technology, or should we have in technology, if we can show here that actually AIs and deep neural networks can be easily fooled.
Unseen Portraits by Philipp Schmidt and Stefan Bogner looks at the algorithms that computers use to see the world and to identify faces. So when a visitor comes in, they have their photograph taken by the exhibit, and then their face is distorted to the point at which a computer can no longer recognize it as a human face. So it asks the question, how much would we need to distort a human face to render it invisible to a computer? 20X by Shannon McMullen and Fabian Winkler lets you experience computer vision from the computer's perspective. So when a computer is trying to see or identify an object, it uses three main parameters: outline, texture, and color. And it cycles through those different parameters until it finds an identification. But with 20X, we're more interested in the process rather than the output. So visitors can come in, cycle through those parameters themselves, and experience what it's like to see as a machine.